Hello everybody. Now that we know about positions, courses, distance, the problem now what we face is to calculate our course and distance from our departure to destination. And that would depend upon the track we will choose. We'll be talking about drumline track, great circle track. In drumline, we'll be talking about parallel sailing in which your departure and destination are on the same latitude, longitude. Plain sailing, when you're sailing oblique, the destination and your departure are on different latitude longitudes. And about Mercator sailing, which is based on Mercator projection. But before we get down to the sailing part of it, how far and how which way we have got to go, I just want to have a recap on what we have learned so far. It's important so that these things are there in your head so that you are able to solve all the problems concerning parallel sailing. So we talked about the Earth being a sphere and axis wherever it joins. We talked about it as north and south, and 90 degrees to the north on your right hand side is your east, and 90 degrees to the left is west. And the semi-great circles which join north and south pole are called the meridians or your longitudes. In great circle, the plane passes through the center of the Earth, and this is the plane of this meridian A, which is coinciding with the axis. Another meridian, another longitude, plane passes through the center of the Earth, coincident with axis. So that means that your plane of the great circles is pointing towards north and south. So if the plane is pointing towards north and south, so your longitudes also should be pointing north and south, and that is what we learned when we talked about direction, that the meridians are the true direction for north and south. So the meridian should be running north and south. Two points can be north and south of each other only if they are on the same meridian. If they are on different meridian, then they can never be north and south. Now the course, if you are sailing along these meridians, your course will be either 000 or 180, depending upon which way you are going, north or south. As you can see here, that it is moving along the meridian. So when you are sailing along north and south, you are maintaining your meridian. You continue to be on the same longitude. We talked about equator. Its plane is 90 degrees to the axis. 90 degrees to the axis is east and west. So the equator should be running east and west. The equator runs east and west, and all the small circles, all the parallel of latitudes are parallel to the equator, so they would also be running east and west. So if you are moving along the equator or along the latitude, you would be sailing east or west, and you would be, if there are 2 points on the same latitudes, then they would be east and west of each other. If they are on different latitudes, then they will not be east and west of each other. So the course along the latitude is either 90 or 270. When we talked about D long is the arc of the arc of the equator, or angle at the poles. So E and D on two different meridians, they will have D long measured along the equator or angle at the poles. And any points on these two meridians will have the same D long, irrespective of where they are located on the Earth, as long as they are on the meridian of E and D. So the D long between these two meridians will be the same throughout. At equator, the D long is also the east-west distance because equator is running east and west. And this is the greatest circle, so the east-west distance along the equator has to be maximum, whereas the east-west distance would reduce as you keep on going further up towards the pole. By the definition of the nautical miles, which is arc of a semi-great circle, the equator is a great circle. So you can convert the d long of 2 points if they are on the equator to distances also. Though at the equator, the angle what it forms is called the geographical mile, which is about 7 feet less than the nautical mile. That 7 feet is insignificant here. So we can always convert the d long between 2 points on the equator into distance. And as you can see, the distance between these two meridians keeps on reducing as you're going up. So this east-west distance between two meridians is called departure and is not equal to the d long in miles. As you can see that the distance is reducing. On any other latitude, when the 2 points are on any other latitude, when they're east and west, then they have to be on some latitude. On that latitude, we use the term departure. Now, when these 2 points are moving north, the distance between them is reducing. Now let us have two ships here on the equator. And when he's saying east and west, that means they have to be on the same latitude, so they are on the equator. And he says that they are 120 miles apart. Now at equator, we can always convert the distance into d long, or d long into distance. So that means the d long between the two ships is 2 degrees. Now if we stare north, that means we are going to stare along the meridian. We will maintain our meridian, as you can see that they are continuing on the same meridian whatever they are going. They have reached two different latitudes because of difference in speed, but the d long between them remains the same as 2 degrees what was there at the equator. The east-west distance between them is the departure, which is no more 120 as which was measured at the equator. The east-west distance between A and B cannot be measured on the latitude of B or A. It lies somewhere in between both of them. So the departure, the east-west distance between two latitudes, which are two different latitudes, lies on the middle latitude. Now, mean is A plus B divided by 2. But we are talking about mid. So mid latitude, there were some corrections given in olden tables for correcting the mean latitude to mid latitude, which are not applicable anymore. But suppose you are asked what is departure, true departure lies on middle latitude, not on mean latitude. When these two ships sail from equator to the latitude what they have reached, what changed and where it was measured? So basically the latitude has changed, or there was a delat, and it is being measured along the meridian. And if you go by the definition of nautical mile, so whatever distance it has covered, the delat is also the distance, because nautical mile is arc of the meridian. And ships have been moving along the meridian, so they have covered a distance of arc of the meridian. So the delat here can also be taken as the distance. Same for A. Whatever arc she has made, that is the distance covered by A. If there was some other point which I am showing you here, the delat between this point and B is the same here as well as here. But they are on two different meridians now. And delat is arc of the meridian. You can see is the same throughout. is the same throughout. So the dlat is the same, but the distance between point here and this is not the dlat because they both are on two different meridians. The distance would be here. So this is important for you to know where you can convert your d-long and d-lat into distances and where they cannot be taken as distances. Now if I just moved A to be east and of B, so what do I infer by it if I say that A and B are east and west of each other? That means they are on the same latitude. Now once they both are on the same latitude, the distance covered by both of them is the same, speed was the same. The east-west distance between them has changed. From 120, it has become less. So, when we say that they started sailing from a particular latitude and they are still east and west, that means the distance covered by them is the same. The dlat made by them is the same. But the east-west distance has changed from equator to the latitude what they have reached. Now, if I sail B along the latitude, come to the meridian of A, so that means she has sailed along a latitude on a course of 90 to 70. In this case, of course, 90 because she's gone east. Now, what has happened? When we move from this long meridian to this meridian, the distance moved by her is the departure, and the d-long made by her is still the same of 2 degrees. So the distance traveled by B is called the departure, which will not be the same as 2 degrees converted into miles, but the d-long here would be still 2 degrees. Here, just an example again. Here, two ships are there on the equator, A and B, and one is on 40 degrees west and one is 20 degrees east. So, d long between them is 60 degrees. If these two were made to go to another latitude here, so whatever the d long was here is still the d long here because they were moving along the latitudes, along the longitudes. So, the d long still there is still 60 degrees, 3600 minutes. But the distance between them, the east-west distance, because they are on the same latitude, the east-west distance between them is not the same as 3,600 miles. If there is another point here, C, which is on latitude of 20 degrees north, the east-west distance between them, as what we saw for the previous case, they were on the same latitude, now they are on two different latitudes, would not be on the mean latitude. The mean latitude is 40 here, it would not be here, but somewhere on middle latitude. The departure would lie on middle latitude. Now, A and C, the daylight between both of them is 40 degrees. From A to C is 40 degrees. Point B and C is again 40 degrees. Between these 2 points, C and B, being on the same meridian, the daylight can be converted into distance of 2,400 miles. Though the daylight between A and C is also 2,400 minutes, but that is not the distance in miles. Though the daylight between A and C is the same, but the distance between them would not be in miles. Daylight is same because it's an arc of the meridian contained between these two latitudes, which remains same throughout, irrespective of where the 2 points would be. But the distance between them would be A and C like this. So this is important for you to remember where you can convert. I'm just giving you an example here. Two ships, and they are 1,200 miles apart, and A is to the east of B. So this distance between these two ships on equator can be converted into distance. And being east and west of each other, that means they are on the same latitude. So whatever distance I have given you here at the equator can be converted into d long. Now A is steering north and comes to the latitude of 60 degrees north. When she is steering north, she has gone on the same longitude. There is no change of longitude. The distance covered by A from starting from equator to reach 60 degrees, that is the d lat of 60 degrees, that is 3,600 minutes, is also the distance covered in miles, 3,600 miles, because that is being done on the arc of the meridian. Now the d long between A and B is still the same. What started because A maintained its longitude. Now let us sail and go west and come to the meridian of B. Coming to the meridian of B. Now what has happened? A has sailed along a latitude. Along the latitude, that means she has gone east or west. The distance sailed is departure also. And she has come back to the meridian of 40. So whatever the d long was there between A and B here, that is the d long she has made. And she sailed from point here to this. So the departure covered east and west is the distance, and the d long made by it is still the same of 20 degrees. So departure taken as 600 miles and the d long is still the same of 20 degrees. Now let us come south and come to 40 degrees north here. So I'm coming to 40 degrees north here. Again, I'm sailing along the meridian. So that means there is no change of d long. There is no change of longitude. Uh, my longitude now here is 40 degrees west. And the distance covered from 60 degrees to 40 degrees was done along a meridian. So that d lat would be my distance also. At 20 degrees, what I have done is also the distance in miles, 1,200 miles. And the d long of A from the starting point is still the same, 1,200 minutes. Now the d lat between A and B being on the same meridian is 40 degrees from north 40 to 40. And that is also the distance between A and B. So the d lat now, because they both are on the same meridian, the d lat is also the distance between A and B. Now, if I had an example when I said two ships north and south of each other, so that means that they are on the same meridian. And then I've given you that 2,400 miles distance of A is 2,400 miles from B. So it is understood that the latitude of A is 40 degrees away from the latitude of B. So if you knew the latitude of B, you can always get the latitude of A by the distance, because they are north and south, they are on the same meridian. The d lat is the distance also, and the distance is the d lat also. Now, A and B, they both steer east. And reaching here, they are again north and south of each other because they are on the same meridian. B has sailed 3,600 miles. So B has sailed 3,600 miles along the equator. So that is the D long made by it also. So its departure, its distance and D long is the same. When I said that both the ships are north and south of each other after sailing 3,600 miles, that means A is also on the same meridian. So A has also made the same D long of 60 degrees. They are north and south. A has also made the D long of 60 degrees. But the east and west distance covered by A is not 3,600 miles. The D long is, if A and B is the same, but the distance covered would be different. So distance covered by B is 3,600 miles. We'll have to figure out how much distance A has done. I will leave you here. If I missed out on some points, I will continue with them when we start talking about solving problems on plain sailing, parallel sailing. Till then, thank you very much for being with me.